Hello, my name is Lonnie Love. I'm a corporate fellow at Oak Ridge National Laboratory. In the summer of 1989, when the Berlin Wall came down, I started dating my wife 30 years ago and still been married, have 3 kids. In terms of research and where walls come down, in my opinion, 2 areas that I try to focus on. One is an additive, really trying to transform the size, the speed, the cost of additive, opening up new markets. We'll show you a few examples. The second area is how research is conducted. I'm a big believer in moonshots, having audacious goals, moving very fast, working in teams. You'll see a number of moonshot projects that we've really kind of pioneered at Oak Ridge. So in 2013, we started the development of the big area additive manufacturing. This really broke down the walls in terms of the size, the speed, the cost of 3D printing, going from a couple of cubic inches an hour to thousands of cubic inches an hour, from a couple of cubic feet in volume to thousands of cubic feet in volume, from $10 to $20 to $30 a pound down to $1, $2 a pound on the material. But the big question is, what were we going to print? How were we going to get people excited? In January of 2014, we had 2 companies come visit. The first was Cincinnati Incorporated. They're an old family-owned machine tool company. The second company was Local Motors, a small startup company that looked at innovations in automotive. Cincinnati wanted to commercialize the technology. Local Motors had the audacious idea of trying to 3D print a car in front of 120,000 people 9 months after they visited. So it led to a very aggressive program where we developed the technology, we tried, we failed, but it really, the next wall we broke down was research at light speed. So it was try things, fail quick, fail often, adapt, modifying material, modifying controls, modifying the system. We had a hard deadline 9 months after both companies visited to show what we could do. Soon after that, we received a lot of accolations. We had the president and vice president coming to Oak Ridge, and I was told, hey, we need to show something really cool. Can you get the Stratty, the car that we printed with Local Motors? And it's like, unfortunately, we can't. It's on their own tour. And they said, well, can you 3D print a car? And this is another, it was like the second moonshot, which is, well, how much time do we have? And they said 6 weeks. When we printed the first car, one of the questions that was asked was, well, this is really fast, but the surface finish is really rough. What can you do about the surface finish? So that led to this. This is the Cobra. We started working with different companies, Polyant, True Design, on how do you finish a car. This was a 6-week project from start to finish. It was a week to design, a week to print. It has about 500 pounds of printed material. The frame is printed, there's a skeletal structure underneath, a week to assemble, and then 2 weeks to do the finishing, and then finally get it on the dynos and get it working. It's a fully functional electric vehicle. It can go from 0 to 60 in about 6 seconds, top speed of about 80 miles an hour, but it really shows innovation in terms of manufacturing, which is what we really are trying to do. Now, is 3D printing cars something that we're advocating? I think it's really interesting. The company Local Motors has actually expanded. They're making 3D printed electric vehicles, electric buses, but really, to me, the killer application is tooling, and we'll talk about that in a second. Another example of breaking down walls is how we're moving quickly to transition technologies from the national labs to industry in times of crisis. So during the COVID pandemic, we demonstrated we could use our metal additive manufacturing to make tooling in days rather than weeks for industry to be able to make reusable N95 masks. We worked with our partners at Coca-Cola to demonstrate that we could make test tubes using conventional Coke preforms, leveraging an existing product, and demonstrate how it could be used for test kits. We worked with Thermo Fisher on both tooling, metal additive manufacturing for tooling for test tubes for test kits, as well as the 96 well plates used in testing. So again, leveraging all the manufacturing and even getting to the point where we partnered with Dr. Peter Tsai and demonstrated how we can make charging systems for mass production of N95 material. We've now transitioned this to Cummins, who's converted an oil filter production line to N95 production. And then they've provided that material to another partner of ours, Dematec, who's now making 3.5 million masks a day. So this is tearing down walls in terms of how long it takes to take advanced manufacturing out of the lab into industry and then to the end consumer.